Sodium is neon, 3s1. Potassium is argon, 4s1, and we'll do one more. Rubidium is Kr, 5s1.
Mama, why you like to be a secretary?
Yeah. I've worked with the public. Put myself through school working in the grocery store.
No,
I got my first paycheck here and quit.
Yeah, I want to quit.
I can work with the public, but sometimes I'd lose my temper.
I try. Because people be trying.
They do.
And then like the customers always like,
No, they're not.
I'm sorry, but no. They're always mad at you. Right. Because they always blame you for everything that goes wrong. Like, it's not my fault. Like, this woman was mad at me because the gum was in the wrong place. She's like, well, you need to change it and you need to fix it. No. No, I'm not. All
right, everybody got it? So, tell me this. What's the highest energy level in hydrogen? Good. The highest energy level in lithium and sodium and potassium and in rubidium. So what can you tell me about the energy level happens in a group? Okay. So in a group, the energy level increases. So if the energy level increases, what's going to happen to the size of the atom? It will increase. Okay? Size will increase. Now, the reason for that is hydrogen has one ring. Lithium has two rings. Sodium has three rings. Potassium has four rings. And if I keep going, I won't have space, but rubidium would have how many rings? 5 rings. So that's why I'm saying if an energy level gets bigger, size will do what? It get bigger. Okay? Does that make sense? Yes or no? Does that make sense to anybody in the room besides just me?
Yeah.
Okay. Well, sometimes y'all just stare at me and I'm like, it doesn't make sense. Okay. So for a trend, as you go down a group, atomic radius increases. Okay, so as you go down a group, radius increases. Now, I forget which homework question that was. Is that 1 or is that 3?
3. The answer is increases.
Yep. 3 was increases. Okay?
I said as you go down the periods. I mean, not periods.
Number 1 was periods. 3 was down. It said family. I think is the way I just read it. Family was increases. Okay? Now, if we put the because part here, if you wanted to actually add the because, why would it increase? Okay? Got increasing energy levels. Okay? If you got this part, there's 3 points. If you get this part, there's 2 more points. If you left it blank, it's -5. If you did the graph, you got a 70. Okay? If all you did was the graph, you got an automatic 70. Okay?
Oh, wait, we were supposed to fill out on the because part?
Yeah.
I thought it was. I told me wrong.
So if you only did the increase and no because, it's -2. All right.
You said if we done a graph, we got a 70.
Got an automatic 70. If all you did was the graph. Did you do the graph at least?
Yeah.
You got a 70.
And I answered some more questions.
And there you go. You got some points there too, hopefully.
Hey.
All right.
Yeah, I did my homework.
Jade's doing improved this week. Very good. All right, so a period trend. So what happens as we go across? All right, we're going to take the second period because it's short, and I don't mind writing these configurations. So let's say we have, won't even do these in shorthand, 1s2, 2s1, jump across to boron, it's carbon. 1s2, 2s2, 2p2. Oxygen, 1s2, 2s2, 2p4, and we'll finish with neon. 1s2, 2s2, 2p6. All right, we got it? All right, so when you look at these, tell me what the highest energy level is in all of them. 2. So is the size getting bigger? No. Okay? The size can't increase. All right? Size cannot increase if energy level stays the same. Does that make sense? Okay. Now, several of you, well, I won't say several of you, I know Tomas yelled it out, said it got smaller. All right? So, if you're one of the people who wrote the size got smaller or decreased for question number 1, question begs to, why does it get smaller? Okay? Some of you probably looked it up online and found a reason that you wrote down that made absolutely no sense. So let's talk about why. Okay? This has 3 protons. This one has 6. This one has 8. And this one has 10 protons. Okay? Think of those protons. They're positively charged, right? Think of them as little magnets. The positive protons pull the electrons closer to the nucleus, shrinking the size. Okay? So, when you look at the protons, who has more protons? Neon. So, if you're thinking about magnets, lithium is a smaller magnet than neon. So, this has 3, this has 6, this has 8, this has 10. So, this would be a smaller pull, and this would be a larger pull. So lithium, only having 3 protons, pulls the electrons a little bit towards the nucleus. But neon has 10 protons. So it pulls those electrons really close to the nucleus compared to those 3. So if these are like little itty bitty magnets pulling those electrons close, those 10 protons are stronger and pulling closer to the nucleus. Does that make sense? Okay. So what's our period trend? Okay. As you go to the right, size decreases. All right? So you go to the right size, decreases. Yes? I do in physical science. I'll be glad to teach you that after class, but not right now. I do a whole unit on it. All right, is everybody caught up? Now, for our visual people, all right? And you don't have to draw this if you don't want to. But for those of you who are visual folks, I tend to be visual. All right? If we go this direction, what happens to our size? It gets smaller. Okay, it decreases. What happens as we go down? It increases. It gets bigger, right? All right, don't worry about the F block because we're not going to use the F block at all. So looking at your periodic table. Who is the absolute largest element on the periodic table? Don't look at the F block. Pretend it's not there. All right, who's the biggest element on the periodic table? Ignore the F block. Who? Francium. All right, Fr, okay, is the biggest element. All right, who's the smallest then?
Helium. That's the hydrogen. Oh, helium is not hydrogen. Helium. Oh.
Helium is the smallest. Now, some of you who are yelling out answers, remember when you said hydrogen, hydrogen is the smallest straight up. But remember, when you get here, what do you have to do? You got to go across. Okay? Now, I'm going to give you 3 sets of questions. I want you to tell me, you want to do largest or smallest? All right? So we're going to pick the smallest atom in each of the 3 sets of elements. All right, in those 3 sets of elements, choose the one that is the smallest in each set. Find the one that is the smallest.
SR.
I want you to do it yourself without yelling it out.
No, is that?
Oh, is that SR? Yes. It's not very good. R, thank you. How about that? Does that look better? All right. I tried to write the rest of them better. Two, three, 4, 5, 6, 7 groups. I still need a few more. Let's do. All right. We got them, or you still need me to wait?
I think it's XR.
SR is in group
Oh, I
2.
see.
About now. Yes, no? Heard a no. Okay.
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 Yeah, sure.
All right. So when you look at number 1, where are all the elements in number 1?
And
In the same group. They're in group 2, right? So what happens as you go down a group? They get bigger. So who's the biggest? Oh, I said smallest. Never mind. Who's the smallest? Okay. So if you put them in order, you have BE up here at the top, then CA, then SR, then BA down here at the bottom, right? So they get bigger as you go down, and we said smallest, so who's the smallest? BE. So BE is the answer. Okay, you with me on that?
Yeah.
All right. So number 2. What'd you notice about all 4 of those? They're in the same period. So who did we pick was the smallest there? All right, that was at least a little more uniform in answer when I asked something. Okay, because we noticed that you had CS over here, and then OS, and then BI, and then RN, and they get smaller. So RN would be the smallest. Now, what did you notice about the 4 that I picked this time? They're in a what? They're in a cube or a box, right? So you had SE, TE, BR, and I. So what happens as you go down? So these are out because they get bigger as you go down, right? So what happens as you go across? They get smaller. So that means that's out. Who's the smallest? BR. Questions? We feel okay about how to do that? Okay? But this is why I said yesterday, if you don't know the trend, can you apply this on the quiz or the test? It's just an eeny, meeny, miny, mo thing. All right. The second one that I know we can get through before 10:20 is ionic radii. And then the other 2, we just might have to wait depending on the bell. We'll just see how far we get. Might be nothing more than the definition. All right, so ionic radii, first of all, refers to an ion. Still a radius, but it's talking about an ion. And we talked about ions way back, I don't know, 4, 5, 6 weeks ago. It's been a while. Does anybody remember what an ion is? It's an atom with something.
With the charge.
It's with a charge, okay? It's an atom with a charge. And there were 2 kinds of ions we talked about. They had names. One started with an A and one started with a C.
Atomic.
Either of those names look familiar?
No.
Okay.
Yeah.
Yes, they
A
do.
little bit.
A little bit. All right. A cation is a positive ion, and an anion is a negative ion. And it's called cation and anion. I told y'all not to call them cations, anions, or any of those other weird names y'all make up. They're called cat and ion.
And ion.
Onion.
Anion.
Yeah, I know. Anion I get a lot. But it's an, like the word and then ion, and then cat, and then ion. Yeah, it's not occasional. You get that a lot.
I'll be pronouncing.
I'll be pronouncing that.
Okay.
Right.
Now, a positive ion, you guys all know things like Na plus 1, Al plus 3, O negative 2, Cl minus 1. Okay? Those are things that we've done that are anions and cations. Now, we want to be able to talk about the size of one versus another. So, if we had something like an oxygen versus an oxygen negative 2. Now, we generally call this the parent atom, and this would be the ion. Now, we call oxygen the parent atom because it's the one that had no charge on it. And then the oxygen with the negative 2 is the ion because, of course, it has a negative 2 on it. Now, if I asked you who was bigger or who was smaller, this is based on your knowledge of what the negative 2 means. Can you tell me who is larger? The what? Why, Justice? Very good. Okay. You guys have to remember, in case you didn't hear what Justice said, that this means you gained 2 electrons. Oops, I left my E out here. You gain 2 electrons. So think about it as you gain 2 pounds. If you gain 2 pounds, are you larger or are you smaller? You're larger. So if you gain 2 electrons, that makes you larger. Does that make sense?
Yeah.
Okay? That's an easy way to remember. The hardest part for most people is remembering that the minus 2 means what? That you gain 2 electrons. If you can keep that straight, most people can remember that that means you're larger. Okay? Now, by the same token, though, if I put up here Mn plus 5 versus Mn, what does that tell you about this? It means it lost 5 electrons, so it's going to be what?
Smaller.
It will be smaller than the Mn. Okay? Everybody remember plus 5 means you lost, right? Okay. Now,
How did it go to 5?
say what?
How did it go to plus 5? Like, didn't it just like what?
It lost those 5 electrons.
I thought you said it would what, gain 3.
Doesn't have to. All right. Now, let's say that I ask you, and I give you those 4 choices. Okay?
Is that BE?
Mm-hmm. Be plus 2. Ouch. What do we do there?
It's BE. That's
It
hard.
is looking at them as the same because they all have the same number and part.
Okay, I hear they're the same. I hear BE and I hear SR.
My answer wrong.
Okay.
You gotta look at the trends. It's the same.
All right, now I hear 2 SRs. I got Jade and Tomas yelling SR. All right, I got another one yelling SR, and I got Samara telling me to look at the trend, which is how they got SR, which is correct. All right, because what do you know about all of those?
They all got
Group.
They all have negative 2, so they're all, or positive 2, so they're all where? They're all in the same group. Okay? So when they're in the same group, you use the trend. So, who's the biggest one? SR. Okay, questions. Now, before any of you ask me, would I give you one with different oxidation numbers? The answer is no. Now, I would if we were in an AP class, but I'm not going to teach you that one. Okay, there is a way to do that one. It's called an isoelectronic series, and I'm not going to do it to you. Okay, I've elected not to teach that at this level. Questions?
No.
All right, are we sure?
Yes.
All right, let's talk ionization energy. We can start it. The only reason I'm saying come on 12:30 is gets me closer to 7.
Somebody's treating me anymore.
Huh?
Somebody's treating me anymore.
You just
Sounds
don't want to go.
fabulous.
You don't even want to go.
Shut up.
It's not
You're
her
right.
friend. It's her mentor.
It's right. It's her mentor.
Why y'all got
She said
Because it's your boyfriend, you were way off.
boyfriend, and it was her
Where are they taking you to lunch?
I don't know. I hope some are good.
Right, it's a free lunch. Y'all are getting to leave at 12:30.
Every time you say boyfriend, we know you ain't going.
I don't care where y'all go. It's beating where I'm going to be. Anything's better than where I'm going to be.
I don't see why y'all have to stay here that long.
We're going to stay, change oxygen into carbon dioxide, and pretend some parents are going to show up between 12:30 and 7 o'clock. All right. Your mom might see more parents than I see. Last time we had spring conferences, I think I saw 4. And most of them just came by to say hello.
Actually, no, she
No.
really don't.
She doesn't get
Because
more?
one time it was like this parent thing. She only got 2 people.
Only 2?
Yeah,
Even I got more than 2.
that was sad.
Dang. Even I get more than 2.
in middle school.
I'm a teacher, and even I stopped going to parent conferences in middle school. Okay. I just don't go either. All right, ionization energy. I don't even go to open house in high school. Go to open house for Shelby. I think I did. I think she made me go.
No.
All right.
I think she was gonna call
She
like,
said they do parent conference.
yeah, like at 12:30.
My mom,
Everybody showing.
my mama don't answer.
I've
My
been
mom
distracted
is
the
a
whole
teacher.
time.
She's not gonna be able to come.
My mom don't even be out till.
Oh yeah, my mom got work today.
Where's your mom work?
What's today?
Well,
Thursday?
elementary.
Oh yeah, my mom got work late today.
She working late today?
I think so.
Oh.
So she worked with the special kids.
Oh, I was going to say she can come if she's not working late today. Just catch up with me. I'd love to see her.
Yeah, I think she. And then she gotta go to my brother's conferences because he go to the same school. So
What school does he go to?
we go to Bolton Elementary where she works.
Oh, okay.
So she gonna be over there all day.
I need to talk to her.
Oh.
Everybody like chatting if you do.
I know. It's terrible. All right, so what's ionization energy? Anybody know? Doesn't sound like it might be.
Ion energy.
Good charge.
Okay, that was not what I was hoping for there. Let's try again. All right. What's an ion?
It's atom with a charge.
Okay, so we're going to do what?
Atoms, and it's the atom with energy.
Okay. Leave out the atom part.
More. It's a charge with energy.
Adding energy to the charge.
Adding charge to the energy.
Okay. All right. Y'all trying. I give you props for that. All right.
At least we can create.
Yes. You're trying. I was hoping for more along that ion line, but we're not getting there.
Ion.
Okay, forget the energy word. Leave that out. Leave atom and energy out.
Gaining
What's the point of an ion? What does an ion do?
it changes the.
Justice, what are you trying to say?
I said it changes the charge of the electron.
I'm not sure why y'all keep saying it changes the charge. That's where I'm losing y'all. What's an ion?
Atom with a charge.
Okay. So, how does it go about getting a charge?
By gaining or losing electrons.
All right, by gaining or losing an electron. So, ionization energy is the energy.
Gained or lost from losing.
Okay, we got to pick one. All right, it's the energy needed to remove one electron from an atom. Okay? Now, ionization energy is strictly about removing, and it has to be for one electron. Now, ionization energy can be for more than one electron. Now, when we say plain ionization energy, it is always first ionization energy. We don't sometimes say first ionization energy. We just drop the word first and just say ionization energy. But if we wanted to say second ionization energy, we would have to use the word second. Now, if we were talking about second ionization energy, how would the definition change?
And you need to remove 2 electrons.
All right, not 2. Alter it slightly.
Second.
There you go. Okay, it's the energy needed to remove the second electron from an atom. Because the first electron would already be gone. Okay, you would have already had that electron removed. So it would be removing a second electron from the atom. Okay?
It's not the same amount as the first.
No, and it would be a higher amount of energy required. The first electron, what? You don't say it's stupid. Okay? So, for example, let's say you have money in your wallet. Okay? It's in his wallet. Now, if I wanted to get $1 from you, I might be able to talk you out of $1. It would be hard, but I might be able to talk you out of $1. Okay? Because you're a nice guy and you might feel sorry for me. And I might want to have bought a candy bar from whoever was in the band who was selling candy bars. And I might have been hungry. And you might have been like, okay, Miss Wall's kind of plushy. She needs some vitamins. And she's going to get a candy bar. But if I came to you a couple minutes later and said, I need another $1, you'd have been like, hey, no way I'm giving her another $1. It'd be harder for me to get another $1 from you, right?
Yeah.
So that's the way ionization energy works. It's pretty easy to lose that first electron, but that second electron is harder to get from the atom. So if I had a third ionization energy, it would be the energy to take a third electron. Would it be higher in energy or lower in energy? It'd be higher. It'd be like me going back to Tomas and saying, I need another $1. Can I get another $1? I need another candy bar. You know, he'd be like, get away from me at that point. He wouldn't give me another $1. Okay? It'd be a waste of my time. All right? You understand what I'm talking about?
Yeah.
I'm on time. I got 4 minutes. Why are you packed up over there?
Oh,
All right? So, based on what we know, all right, in a period, let's talk about a period. What do you think would happen if you went across, okay? We know that we start at 1 electron, 2 electrons, 3. I'm not even going to draw it as a periodic table. Right? From 1 to 8. What's going to happen as we go from 1 to 8 electrons? Does it get easier to remove an electron or harder? That's right. As we go left to right, it gets harder to remove an electron. Why would it get harder to remove an electron?
because you have to take all the other ones.
That's right, because we're closer to having how many? We're closer to what number? That's right. because we're closer to 8, or that magic word we always refer to as an octet. Okay? So, as we go across a period, ionization energy does what? It increases. There we go. Now, think. All right, not giving you any homework tonight since I made you work hard the last 2 nights. Now, I will tell you that we're going to do a puzzle possibly tomorrow in class, but most likely Monday. And it will count as a lab grade. And you cannot use your notes. And we will have a quiz Monday also. Okay? So we'll finish this and probably start bonding tomorrow. Because our schedule's a little jacked up. Normally we would finish all of this and do the lab tomorrow. But the early dismissal day is throwing a monkey wrench in our schedule. Yes.
Why did they put it on today instead of tomorrow?